Often overshadowed by its neighbors, Uranus is one of the most mysterious planets in our solar system. Though it may appear quiet and pale blue through a telescope, this ice giant harbors secrets that continue to intrigue scientists, especially when compared to its planetary sibling Neptune. Uranus has a mass of approximately 14.5 times that of Earth, slightly less than Neptune's 17 Earth masses. Yet its diameter is slightly larger, about 50,700 kilometers, roughly 4 times that of Earth. Because its mass is spread out over such a large volume, the surface gravity of Uranus is surprisingly gentle, clocking in at around 7.8 meters per second squared, or 0.89 times the gravity of Earth. Standing on a solid platform floating within Uranus's atmosphere would feel quite natural to us. It's one of the few planets where a human might feel relatively at home in terms of gravitational pull, though the rest of the environment is anything but welcoming. What lies beneath that aquamarine haze? Scientists believe Uranus has a small rocky core, roughly the size of Earth, made primarily of silicate and metallic elements. Surrounding it is a thick mantle of water, ammonia, and methane ices, hence the label ice giant. Above this is a gaseous envelope of hydrogen and helium. Despite its frigid distance from the Sun, Uranus radiates very little internal heat. In fact, it emits less heat than any other planet in the solar system. This lack of thermal energy makes its weather systems more subdued than Jupiter's or Saturn's, but not non-existent. Cassini did not visit Uranus, but data from the Voyager 2 flyby and later observations from Earth-based telescopes have revealed massive storms, atmospheric bands, and high-altitude haze layers. Another strange aspect of Uranus is its axial tilt. The planet rotates on its side, with an inclination of about 98 degrees. This means that its poles experience 42 years of continuous sunlight, followed by 42 years of darkness. Such extreme seasons have profound effects on its climate and atmospheric dynamics. In recent years, interest in Uranus has resurged. Scientists now suspect that its odd rotation and structure could be the result of a massive collision early in its history, possibly with an Earth-sized object. That event could have disrupted its core, altered its magnetic field, and tilted its axis dramatically. A future mission to Uranus, similar in ambition to Cassini's exploration of Saturn, could revolutionize our understanding. The data we have is limited, and the ice giant's distance makes missions challenging. But the scientific payoff could be enormous. Insights into planetary formation, atmospheric chemistry, and even magnetic field generation. At Infinity Beyond, we see Uranus not just as a planet, but as a puzzle, an invitation to look deeper, to ask more questions, and to prepare for the next great journey into the outer solar system.